Today we are going to solve the 21st problem in 30-day lead coding challenge. The problem name is leftmost column with at least a 1. Let me open the problem. Let me read the problem. A binary matrix means that all elements are 0 or 1. For each individual row of the matrix, this row is sorted in non-decreasing order. Given a row-sorted binary matrix, return leftmost column index start from 0 with at least 1 in it. So at least 1 in a column in it. If such index doesn't exist, return -1. You can't access binary matrix directly. You may only access the matrix using binary matrix interface. Binary matrix.get xy returns element of the matrix at index xy 0 index. Dimension returns list of 2 elements nm, which means matrix is n cross m. Okay, list of 2 element. Okay, summation. Okay, more than 1000 calls to binary matrix.get will be judged wrong answer. Also, any solution that attempt to circumvent the judge will result in disqualification. For custom testing purpose, you are given the binary matrix mat as an input and the following for example. Okay. Well, matrix will be given. Matrix, each row in the matrix are sorted, and we have to return the index of the column which contains at least one. Well, if we have no limitation like making 1000 calls, this is a limitation. Let's see what is the limitation of row and column. Mat.length. Okay, row and column can be at most 100 and is either 0 or 1 element, and it's sorted in non-decreasing way. Okay, which is already mentioned, but the dimension would be at most 100. So if we want to traverse over the given matrix, then the size of the matrix is 100 cross 100, which is equal to 10,000. But we have limitation that we cannot make more than 1000 calls to the binary matrix.get. So in that case, the iterating over the given matrix and then after trying to find out which column contains at least 1 will not be a good solution. And we will not be utilizing the fact that the given matrix are sorted row wise. Every row are sorted in increasing order. Well, so given this fact that row are sorted, what I'm thinking that we can apply the binary search over every row because the row are sorted. So we can find the entry, like for this example, we can find, for if we search binary search in 0th row, we find out that the 1 exists in 4th column, and this will give us 4, and in second row we get 3, and third row we get second column as an answer, but we return 1 because the second column is our answer, and we have to return by 0 index, so it is the first index, so we are returning 1. Well, so if we perform binary search in every row and collect those columns and try to relax those column index every time we do binary search, we will get the final column index is our answer. Well, so if we perform binary search, then the number of calls we will make will be like log n in each row. So for every row there could be like at most 100 row. So row will be at most 100 and column will be at most 100, and the number of calls we will make will be row times log of column, which is our time complexity as well. Which will be equal to row is 100 at most, and log of column log 2 of column 100, which will be equal to 100 into log of 100 is like 7, which will be equal to 700. So 700 call can be accepted. Let's go for the implementation then. Let's find out the row and column. So according to problem statement, we will get it in a list. So which is a vector of dimension given binary matrix that dimensions. Okay. So we will get a number of rows which will be dimensions dot dimension 0th index of the dimension, and columns will be dimensions 1, and let's iterate over every row. And from each row we will do a binary search. Let's start binary search over here. High is equals to column minus 1. So we define a range where we will do a binary search. And we will find a mid value in binary search. Now value at this index, mid index in that row, is great. I mean, based on the condition, we will be finding the we'll do binary search to find lowest index of index having 1. So basically we say this is as a lower bound of 1. So if it doesn't exist, then we will keep track of that as well. Well, let's define our answer as a answer, and we will be, every time we find a some column entry, we will try to minimize this column for every row, whatever answer we are getting. we will try to minimize that answer. So basically from each row we are getting that this column will be leftmost, but at the final the one will be leftmost, which is minimum among all the answer we are getting from every row. So let's keep answer as some maximum value and int max. Well, if it doesn't exist, then what we have to return? Okay, if there is no anyone, then we have to return -1. Well, we have to keep track of that as well. Well, for each row, let's define the index exist in our lower index lower one index one column, say lower one column, which is, let's say, we will try to minimize this. So initially let's put it as a column, and every time we get, we'll try to see whether it is 1 or not. So let's say, let's find out the value first. Binary matrix, we are making a call get x and y position. X position is row and y position is mid. If it is equals 1, then we will try to minimize. So we move our boundary. So now our boundary, the range, the among two half, like low to mid and low to mid -1 and mid to high, there are two ranges over which we have to choose only one range. So let's, in this case, this is valid, so we will try to find the one which is which may be of lower column index. So let's make high equals mid -1, and let's try to minimize our answers. So now lower one column will be minimum among lower one column and this mid position. Well, otherwise we will, if it is not 1, then it is 0. So we have to find a range. We have to take the right range. So in this case we are taking the left range because the right range is valid, and we are going into left range to see whether left range contains other valid one index or not. But in this case, if it is a 0, then it is not valid, so we are not updating anything. In this case, we are just changing our range from left side to the right side. So that to go to the right side, we have to move our left boundary towards the right. So in order to move the left boundary, we have to update left boundary from mid to low will be mid +1. Well, finally, if we see that if lower one column is not equals columns, if it is equals column, then it is not updated. So we didn't get any valid index having 1. In this case, if it is not column, then we will try to, our answer will be, we will try to minimize our answer index. So we will try to minimize this column index because we want to have a leftmost column in the final. So we will return now our answer. If answer is equals int max, then we have to return -1, otherwise we will return answer. Well, let's run this code. see if there is any compilation error. As expected, row and mid rows 26. Row is I here. Let's try with other cases. 0 0 1 1. The answer is 0. Yeah, let's make it 0. The answer should be 1. Yeah, let's make it 0. Answer should be -1. Yes, let's submit the problem. Well, it is accepted. 8.1 megabyte and 8 millisecond. Well, thank you so much for watching this video. Hope you like it. Have a nice day.